Hello, calculus fans. Okay, so let's try computing the derivative of a to the x, where a is any positive number. Now, we've computed that the derivative of e to the x is e to the x, but we're going to try to expand on that. We're letting the base be anything, doesn't have to be e. So the way we're going to pull this off is we're going to rewrite a to the x. So the first thing I'd like to do is just rewrite a as e to the log a. So remember that the exponential and the log are inverses of each other, so a has to be equal to e to the log a. Now, we're not doing anything fancy here, that's just a manipulation algebraically. And now we know that if we have a power on top of a power, like we do here, we can just multiply those powers, and so that's why we end up with e raised to the log a times x. Now it's very important to keep in mind that log a is just a number. So this thing right here, you may as well be thinking about something like e to the 5x. It's just the same kind of thing. The number in question in front of the x is log a, but it's still a number, and that's very important to keep in mind. A lot of people will lose sight of this and think that something funny is going on. Log a is just a number. All right, so we're ready to compute a derivative. So we've rewritten a to the x as e raised to the log a times x. We're going to use the chain rule on this because there's an outside function, which is the exponential, and an inside function, which is log a times x. Now we know that the derivative of the exponential is the exponential, but now we have to multiply by the derivative of the inside. So we're multiplying by the derivative of log a times x. I want to emphasize that this thing now that I've boxed, this is supposed to be really easy because log a is just a number. If I asked you what is the value of the derivative of 6x, you would not hesitate to say that answer is 6. But if I ask you what the derivative of log of a times x is, some people would hesitate. And I would say that you shouldn't hesitate because log a is just a number. So that derivative has to just be log a. Don't think about it too much. So here's our final answer. We just get e raised to the log a times x, and then that whole thing times the number log a. I'd like to rewrite that first part, and we're going to have a formula now that I think is worth memorizing. So we get that the derivative of a to the x is equal to a to the x times log a. So this piece here, we're basically rewriting it just as we did here, but we're going back to rewriting it as a to the x. So this formula that we have down here, I would like you to memorize this just as you've done with all the trig functions and things like the power rule, product rule, quotient rule. These are all things that have to be memorized. We're building up a list of things that you need to have committed to memory, and you have to have them committed to memory because we want to be facile with our computation. We want to be able to move quickly with computing derivatives. Later on, we're going to be doing a lot more calculations that really require us to be fast with computing derivatives. We don't want to have to look these things up. Now, just to remind you, way back in the last chapter, we actually computed the derivative of a to the x, and we calculated that the derivative of a to the x is a to the x multiplied by the limit as h goes to 0 of a to the h minus 1 all over h. Might be worth going back and looking at that calculation and seeing how we use the definition of the limit to make this computation. So what we've shown now actually is that the number that we get out here has to be the same as this limit. So under the assumption that this limit exists, which by the way we haven't actually proven, what we have shown is that if the limit exists, then it needs to equal log of a. All right, so the big thing to take away here is this derivative, which we will use quite a bit. Okay, that's all for now.